Good day, ladies and gentlemen, to our second part of the well intervention training program, which starts with week 7. I commend you all that have made it this far to the second part of this training. Today, we will explore advanced coiled tubing operations and case studies. This session focuses on understanding coiled tubing technology, its equipment, applications, and lessons from real field operations. Before we dive in, you should be conscious of your environment. Identify the mustering points, your exit. Should there be any issue, you don't have to run. Walk very briskly. Make sure that the gangways are free of any obstruction, any slippery floor. Then you go to your mustering points for a head count. Now, coiled tubing is a long, continuous steel pipe stored on a reel. It's used to perform well intervention without killing the well. Unlike joint pipe, which is usually used during rig operations, coiled tubing is flexible and can be run into live wells under pressure. The main advantages are cost reduction, quick deployment, and minimal formation damage. Coiled tubing versus slickline operations. Let's talk about that. Let's compare coiled tubing to slickline operations. Slickline is purely mechanical. It sets or retrieves tools and valves, while coiled tubing, on the other hand, provides pumping and mechanical capabilities. When slickline stops, coiled tubing takes over, especially in fluid circulation and downhole cleanouts. What are the application differences? Slickline operations include gauge retrieval, valve manipulation, and plug setting. Coiled tubing operations, on the other hand, handle heavier duty tasks like sand cleanouts, nitrogen lifting, and acidizing. Both complement each other during integrated project management. Slickline for precision, coiled tubing for power and circulation. You just have that in the back of your mind. Coiled tubing equipment overview. If you check the slide very well, you can see a picture of a complete truck-mounted coiled tubing unit. The coiled tubing unit has 6 key components. 1, the reel. 2, the injector head. 3, blowout preventer. 4, power pack. 5, control cabin. And 6, the coiled tubing string itself. Each part plays a specific role in ensuring safe and effective well intervention. We'll talk about them one after the other, that is, the 6 key components. Let's start with the coiled tubing reel. The reel stores the continuous tubing string, sometimes several thousand meters long. It uses a hydraulic brake and tension control system. Proper spooling and handling are critical to prevent tubing fatigue and collapse. The injector head. This is the muzzle of the coiled tubing unit. It pushes and pulls the tubing in and out of the well bore using hydraulically driven caterpillar chains. It must provide smooth motion and maintain proper tension to avoid tubing damage or tubing slippage. Sensors monitor the pull and push loads for safety. The blowout preventer. Many of us would have by privilege seen one, but if you've not seen, look at the slide. That's the typical representation of what the blowout preventer looks like. The BOP, otherwise known as the blowout preventer, provides well control during live operations. Coiled tubing blowout preventers have multiple ramps: blind, shear, slip, and pipe ramps. 4. They call them quad because there are 4. They seal the well bore or cut the tubing in emergencies. The operator controls it from the control cabin. The control cabin. The control cabin is the brain of the operation. It displays real-time data, depth, pressure, pump rate, and injector tension. Operators can shut down the system instantly using the emergency shutdown function on the control console. They usually call this ESD, emergency shutdown function. The power pack. The power pack provides the hydraulic energy for the injector and reel. It's usually diesel driven, supplying consistent power. Hydraulic stability is essential for smooth coiled tubing movement. The coiled tubing string and specifications. Coiled tubing strings are made from high-strength, low-alloy steel. They come in sizes from 1 inch to nearly 3 inches in diameter. We choose tubing based on depth, job type, and fatigue life. Each run adds to fatigue, so careful monitoring is mandatory. Intervention techniques. Coiled tubing can be used for milling, sand cleanouts, acidizing, nitrogen lifting, logging. Its versatility makes it the go-to method for many complex well interventions. Go-to method for many complex well interventions. Let's take them one at a time to further expand our understanding. The milling operations. Milling is used to remove hard obstructions like scale or cement. We use mills attached to motors and jars to cut or grind the blockage. ROPM, weight on beats, that is WOB, and fluid circulation must be controlled carefully to avoid equipment damage. During the cleanout operations, what do? Sand and scale buildup restricts flow. We all know that. Coiled tubing cleanout uses circulation of fluid. The fluid could be water, it could be brine, it could be nitrogen to remove these deposits in the well. Proper fluid velocity ensures debris is lifted out effectively without deposition. Acidizing operations. In acidizing, we inject acid through the coiled tubing to dissolve near wellbore damage or open up plugged zones. Two main types: the matrix acidizing and fracture oxidizing. Coiled tubing gives precise depth control, preventing acid from entering unwanted zone. The nitrogen kickoff. When wells are dead or liquid logged, nitrogen gas is pumped through coiled tubing to lighten the hydrostatic column. This allows the well to start flowing again. It's an efficient, low-cost rejuvenation method. The advantages of coiled tubing intervention. Here's why coiled tubing is preferred. It works in live wells, faster and more economical than workovers. Minimal environmental footprint, enhances well productivity with less downtime. Operational challenges. Despite its benefits, coiled tubing has challenges. Tubing fatigue over time, injector chain wear, managing high pressure operations, corrosion from acids and fluids, treatment fluids. Each challenge requires preventative maintenance and skilled handling. Case study: coiled tubing fishing operations. Let's discuss a real field example. A Slickline tool was dropped and stuck at 8,000 feet. Coiled tubing was deployed with an overshot and jars to retrieve the fish. Circulation helped clear debris around the fish, allowing successful recovery. Execution and learning. The lessons learned. The first attempt failed due to debris around the stuck tool, otherwise known as the fish. The team adjusted strategy, circulated the hole clean, and applied controlled jarring. Lessons learned here, therefore, is this: always assess debris, well fluids, and tool configurations before fishing. Summary of key learnings. Coiled tubing extends the operational range of well intervention far beyond just Slickline capabilities. Success depends on job planning, equipment selection, and real-time monitoring. Coiled tubing remains an indispensable tool in modern oilfield intervention. To wrap up, let's reflect on these questions. How does coiled tubing differ from Slickline in live operations? We've got all the way from week 1 to week 6. We've studied Slickline in real life situations. How does coiled tubing differ from Slickline itself in the live well operations? What are common risks during coiled tubing fishing? Next week, we'll explore, that is on week 8, we will explore wireline logging and diagnostics. This is another crucial phase in well services. So thank you very much for your attention. I hope to see you by next week in the remaining part of the training. Thank you.